that you've done quite some effort, okay? So there is you will be getting some feedback. Let's see if you can have the marks by next week, okay? And with the feedback. During the interview, we already started telling you some of the things. Okay, maybe this looks very long, or maybe, why did you put this static, or why did you catch the exception like this, or why did you do, the throw exception in the main that I said no, okay? So these sort of things, we already gave you a little bit of feedback about that. But I am overall really pleased because I see that you've been making an effort to use different collections. And I know that, from experience from previous years, I really appreciate that you've made that effort, okay? Which is what you are supposed to be doing, in any case. But I'm really pleased to see that you've managed to do that, okay? So today we are going to be talking about concurrency. If we have a little bit extra time at the end, I will give you some hints on stage 2, okay? Which is, I would say, probably it requires less writing of code, not so much coding, but it is a little bit more stressful mentally. Okay, you need to think a little bit harder about how to solve it in an efficient way, and that it works. Okay, that it works not only in some cases. As you have seen, the test files that I gave for yesterday for the interview were not that very, but some of them were not working. Okay, so that tells you that you need to practice and test your code as and push it. Very good. So let's start talking about concurrency. So actually last Wednesday, we started talking about what is concurrency. Note that this is actually, after this, the next thing that we have is just Zoom. So we start programming graphical user interfaces. So really, we are almost finished with the material. This morning I was like, really, is it really concurrency already? So yes, we are very soon we will be finished, okay, with all the contents. So what happens with concurrency? So we're going to be talking about what are threads and what is the multi-threaded execution of things, and I'll tell you what are those things. And we're going to be talking about synchronizing access to shared resources, because this is shared resources is really the problem in concurrency. And we are going to be talking about 3 main things: race conditions, the use of this synchronized keyword in Java to avoid problems when you are accessing to shared resources, and something called guarded blocks. Okay, so basically, what is parallel processing? Parallel processing is when you are trying to do things at the same time, okay? But at the same time, what does it mean really at the same time? So we've got here a few examples. So if I look at my computer, any computer, we got that there are continuously being reading and writing into the disk. When I'm typing, this is transparently happening. I'm reading whatever I'm typing in here. I don't think it was. So I was, when I'm typing on my keyboard or I'm moving the mouse, all those things are happening magically at the same time. Okay? Play music. So there are 2 main ways of doing things. One thing is called multitasking, and the other thing is called multi-threading. And from the outside, it looks like things are happening at the same time. Okay? But there are some important differences. Okay? So when I talk about multitasking, what we are talking is that we got like separate processes. For example, this one can be reading, writing from the hard disk. The other might be another program and another program. Okay, so they have their own code. They use the same set of data, and they produce and write the same, certain number of files. Okay, but they are like silos. They are not really sharing anything. Okay. Examples: multiple programs in my computer. Have iTunes, Word at the same time. They do not really talk to each other. We are multitasking. Okay. Now, if we want to communicate between these processes, what happens is we do it via the file system or via the network. But they don't really share the same area of memory. If we solve these concurrent things happening at the same time, simultaneously, if we solve it using multi-threading, what happens is different. We got at one process different pieces of code, and they are having a shared access to data and files. Actually, this is what causes all the problem. Okay, and that's the example that I was telling you the other day. When we go to a bank, when we are trying to buy a train ticket, whenever there is something common and many people are trying to access to that common resource, you need to organize that resource. If there is infinite resource, there is maybe no problem. No. You need to know how much you have and how much you got left. Okay? So you need to be very careful, and we are going to see some examples today about that. And those are the things that we will be discussing today. And how in Java you can prevent problems from happening. Now, concurrency is a very complicated topic. Okay? There are books like this thick only talking about concurrency. So here we are really just scratching just the surface. One clear example of a concurrent system is, my computer. When I have my computer, I already described it. You got multiple programs, you got the keyboard, you got the internet access. So it's a living thing. Okay, there are multiple things coexisting and running at the same time. And actually, an operating system needs to be very smart about how to do all those things. Okay, so an operating system is a classical example of concurrency, where you can see where you need to prevent problems from happening. Okay? Good. So let's talk now about more examples on multi-threading. So if, for example, I got a Word, my Word program running, the grammar checker is concurrently, it's going to be one thread. Okay? Or the one, when I'm loading a web, you can see and interact with the page while it is being loaded. So there are multiple things happening at the same time. So you are used to work with systems that employ either multi-threading or multitasking. Okay? So now we will focus on multi-threading and how in Java we deal with this. Okay? So let's talk about one particular example. So imagine that we want to count the number of words in all the files in a particular directory in my computer. Okay? What do I need? How do I do it? There are multiple ways of it. So, for example, what I got there is my list directory, in this particular folder. You will need to get the list of all the file names in that directory. And what would you do? Well, first, count the first file, right? When I finish counting the first file, I go to the second one. And when I finish counting the second one, I go to the third one. And if I got 3 files in my folder, I add them up, and then I got the total. Isn't it? Classical iterative solution, right? But what if I can have multiple threads? And now we can think of it, well, what do I need to do that? Well, we can discuss about that, but that's a separate conversation. But if I want to run that at the same time, how do I do it? I would just create 3 separate threads that know how to count the number of words in a file. And I throw them, I start them simultaneously. Okay, I say start, start, start. Start counting file 1, start counting file 2, start counting file 3. Okay? When the 3 threads finish, I add them up. Okay? It's okay, right? No major deal. Do we agree that that's a possible alternative, a possible solution too? Yeah? Sensible? Common sense? Yeah? It would be like we got you, and then I give you one file, and you give your one file, and I give you one file. And you got the 3, the same algorithm to count the number of words. Okay? So yes, you can, instead of asking you to count the first one, and when you finish the first, you go to the second, and you go to the third. Okay? This is particularly, okay, let's move on. So now, I'm going to show you another example where this is actually very useful. When we go and we move to Swing and we are visualizing things and objects or elements or whatever, in my graphical user interface, usually you need to be doing multiple things at the same time. So this is an example of Swing. We will not understand yet the part of this of Swing, of the graphical user interface, but we are going to understand that these little balls, okay, I'm going to be animating them in my window, okay? And the functionality of what's going to happen and what I'm going to show you is that whenever I press the button Start, one ball is going to start, and I'm going to start animating, okay? And it's going to be following a particular path in my window, okay? And my objective is as silly as clicking and seeing how the balls are moving in my window. So this is clearly an academic example. Okay, so let me run the code. Can you see can you read from the back? Not the bottom, here. Can you read it? Not really. Okay, I'll try to fix that. I'm going to run it, okay? Now. Okay, so I'm going to click, forget about anything that you see in here. The idea was working. Okay, so I start, okay? Okay, I'm going to tell you whenever I click. Click, 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 click. I'm not doing anything. What's happening? I'm not doing anything, okay? And whenever I click, there should be a ball appearing. Okay, now I'm going to show you the right operation, okay? What I want to happen. So if I go to the bounce thread, and now in this solution I'm going to be using threads. We're going to discuss what this is doing, okay? So now I'm going to tell you whenever I click, 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 click. Okay? So what is the main difference? What happened for now I stopped and it just finishes the animation and that's it. Okay? So if I start again clicking, click, 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 okay? No more balls appearing. Okay? What was happening before? I was clicking, but what was happening? Sorry? Delay? Okay, I'll show you again. Okay, maybe you should have started with the right solution and then the bad solution. Okay? So I'll give you. Let me show you the bad bounce. So. Yeah, I click, 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 what's happening?
One is happening after the other is.
Exactly. They are not working concurrently. Okay? You know, whenever I click, it's like they are buffered. Okay, the clicks. You know, if I've done 5 clicks, there's going to be, you know, until I don't finish all the bouncing of the ball, the second one is not going to start. Okay? So it's like the example with the files. I'm first animating the first ball, and when it's finished its animation, then I go for the second one. And when I finish the animation of the second one, I'll animate the third one. And so on. Okay? What did I want it to happen? More likely the second one. Whenever I click, I am responsive. You know, I want it to happen right away. When I click, start animating, start animating. So the solution here, it's using threads, okay? Which is the mechanisms that I have in Java to start things happening whenever I say so, okay? Good. So, yeah, let's have a look and analyze the example, okay? Good. So if I look at my, well, something that I don't know if you noticed, but in the one that it is consecutive or sequential, okay, that things are happening sequentially, it also started like flickering, okay? It was not the smooth animation anymore, okay? So there was some sort of interference even with the graphical user interface, okay? So, good. Let's have a look at this little piece of code, okay? This is when the animation is really happening, okay? So what I got is a class, an object type ball, which will have basically a location, possibly a size, okay? Comp, we don't know what it is, but comp is my graphical user interface, my little window, okay? And I am adding a ball to that window, okay? Or that frame. That's the terminology that we usually, or component in this case, in string, okay? So I'm going to say that for a number of steps, okay, I'm going to be moving the ball, okay? And I'm going to be painting it, okay? And I'm going to do something called thread sleep delay. So when I put a thread, you know, when I call, so can someone tell me what is this sleep? You know what type of method? Okay, it sleeps, okay? Basically it stops and waits for the amount of time that I specify in delay. But what can I say about this method in the way that it is being called?
Static?
It's a static, okay? It's a static method. So just, how do I know that? Because thread is the name of the class, and I'm calling thread dot the name of the method. So I know that it is static, okay? It's like when I use math.sqrt or math.cosine, okay? I know that they are static, or math.phi. So this method, what does is like, it will stop the execution here for this amount of time, okay? So the class thread, and we will see what are the methods in the class thread. We will see that the class thread has one method which is a bit stops, kind of, you know, asks for waiting, and nothing happens, okay? Good. So I'm basically moving my ball, okay, within the bounds of my component, which is in this case this window, okay? There's a lot of code that you don't see, but this is when the animation is kind of happening, okay? And it's happening for a number of steps. Good. So, what's happening in the bad bounds, which is the first example, that's the one that is not working well. This is time, user start clicks, clicks, okay, does this clicks? It's, you know, I got someone checking the input, so checking the mouse, okay? And then, as soon as whoever is checking the input detects a start, you know that I have clicked the button start, it starts animating the first ball. Okay? What happens next? Well, until the first ball hasn't finished the animation, the checking input will not process that second click. Okay? And this is why it will start animating ball number 2 just when it is able to cross the start line. Okay? So this is sequential. Okay. So how are the ball animations scheduled? Sequential. We already know that. Okay? So the good solution using threads. How is this done? So the user is going to be clicking the start, okay? And again, another click of the start button. But now, I have someone checking the input all the time, okay? Not just I'm doing either or, no? I cannot do and, two things at the same time. No, now I'm checking my input all the time, okay? So I start animating my ball, and since I'm checking the input all the time, as soon as I click again the start button, I can start animating the ball number 2, okay? And what I got here is basically 3 things running concurrently, okay? So I got like 3 threads. So how is this done? Okay, so I will have something called ball runnable that implements runnable interface. Okay, so I should have asked that. What is runnable? Runnable is an interface. I already said it. Okay, and okay, the interface runnable. What is it telling me? Now you need to answer. I've already told you that runnable is an interface, but which methods does it have? Run. Okay. Does it have anything implemented in the interface? No, it's completely empty. Okay, it's just a skeleton, a declaration of how things should happen. Okay, but I know that it does have. Sorry, you need to have a method run. So I'm implementing the run method, and what am I doing in the run method? The piece of code that I just showed you earlier. Okay, the one that it is actually animating the ball and painting it. Okay, here component repaint. Here is when I'm saying paint the ball. Okay, here I'm moving it. Okay, the class ball has a method move. Okay, which is going to move the position of the ball according to the size of and the area of where it is moving. Okay, and it's gonna be repainting. And see if I don't do the slip, what happens? What would happen? Why do I need to have this slip? Too quickly. Okay? Our computer is much faster than our vision. Okay? You know, if we remove that line, it would just go. Okay. You wouldn't even see it. So this is why I need to use the slip to delay and be able to actually see and appreciate what's happening. Okay? Good. So my run method is where I will be placing what my thread will be doing. Okay, this little process that I'm going to be running concurrently, I will have some class, okay, that will implement runnable, and in the run method, I will place the piece of code that needs to be run, and it's like that. Okay, it's like that. Okay, so good. So now if we look at how we do this, okay? So I am creating the ball, I'm adding the ball to my component, I'm creating a runnable of type ball runnable, and I know that these are, okay, these are, I'm passing as a parameter b. I'm not showing you here the constructor of ball runnable, but clearly the constructor gets a ball, okay, and this is why run knows that it's going to be moving that ball, okay. This is implicit here, okay. And I'm creating a thread, new thread, and I'm telling that thread what you need to execute. You know, the piece of code associated to that thread that I am starting is in the variable r. R needs to be something, an object that implements the runnable interface, okay? And it works just like this, okay? Believe it or not, it does work. Java knows how to interpret, okay? And knows that if it is runnable, that's the piece of code that is going to be run. Okay? And one important thing, I need to get started my thread. If I don't start it, it will not start doing anything. Okay? I choose when to start that thread. So, good. Which is like the major execution. Now let's do an abstraction. So, threading basics. What happens always? You know, we will always have something that it is runnable, okay, and it will have a method run, which is the one that is going to be doing the particular task, and I will attach it to a thread, okay, and then I will request the thread to start. So these are always the 3 steps that happen when you want to start, you know, running things concurrently. Okay, here I only have one thread, but just imagine that I put a for loop. Okay, I put a for loop, and then I can have 100 balls running. Okay, and there will be all, you know, there will be 100 threads, objects of type thread. Okay, and I will be attaching to them object runnable that has the animation of the ball. Good. So, okay. Now, we can interrupt threads, we can wait for them to finish. Let's have a look a little bit. So, if we look at the class thread, we got the start method that makes it start. It has the join, and we will see a bit later what it does, but basically it's a place where it says, okay, I will wait until all the threads, you know, join and finish. You know, I will not go afterwards until all the threads finish. Okay? I will not let it move forward the execution. As we very well guessed earlier, the method sleep is static, okay, and it just stops the, you know, kind of the execution for the amount of milliseconds that I provide as an argument. Yield is gonna just wait until someone else finishes, and then it will continue. So it's a little bit like semaphores, okay, and we are organizing the execution of things, okay, and saying, okay, well, stop, or just wait, you know, red light, or, you know, or it's a little bit like organizing traffic, okay, the traffic of multiple executions at the same time, okay, someone saying, no, now you, or, you know, maybe like conductor of a orchestra, right? You got different instruments all at the same time. You say, you now, or now everyone at the same time, okay? So, or now silence is needed, okay? So, you got these sort of behaviors, and you can interrupt, okay? No, please stop. Okay, you're doing something wrong. Okay, sorry. Okay, so you got all these different facilities. You can stop the different threads, or you can start them, or you can put them to sleep. Okay. Now, so we've seen 2 alternatives for the counting threads. The first one is the iterative, and the second one, and sequential, and the second one is the threaded one. So if we look at how to solve them, you will see that in the example code, you got different versions of the token counter. You've got the token counter of Java, the token counter 2, 3, and you will be looking at these different examples, okay? So the standard iterative solution, what it does is that I get the method count words, it gets an array of files, and it's going to be iterating through all the files, and it's incrementing the, you know, count tokens counts the words in one file. So whenever I finishes, it increments total, and when I finish iterating through all the title, through all the files, I just return my total. Okay? So this is clear what it does. If I implement it as a thread, you know, things are starting being different. So my count words will get a list of files, an array. Look at that. I can use collections too. I'm creating a collection of threads, and I'm just basically saying that my TS is going to have an array list, a concatenation of threads. And how long is going to be that array list? Well, it will have as many threads as files in that particular directory, okay? In this array of files. So I iterate through my files, I create one thread per file, and again, remember that we've seen that already with a comparable. We are on the fly creating a runnable object. We don't give it a name. Okay? I don't have the bold runnable that I had before. Here it would be the count words or count, word count in my file implementing the runnable interface. I just on the fly created, and I defined my run method as that increment. Okay? Does it make sense? I add the thread to the collection of threads, and then I start that thread. Okay? So is this part clear? Do you understand that this works? I haven't finished here calculating. So what I got in here is as many files. Imagine that we've got n files. I'm creating n threads, and I'm all starting them all really quickly, iterating through all the files and saying start, okay? Of course, if my file has 2 words each, it will be very quick and it will be almost sequential. But if I got files with gigabytes, okay, and some that are very short, okay, there will be threads that take longer to execute than others, okay? And now, over here, what I'm doing is iterating through my array list with all the threads that were computing and calculating the number of words in each file, and I'm waiting them to finish, okay? Until they are not all finished, I will not move to the next line, okay? And when they all have finished, I will return the total. Because over here, the run, okay, is counting all the totals, the tokens for each of the files, and is updating the variable total. Is there any problem here that you can think of? Is there any problem? Does this work always? If the file is empty, okay, well, the count tokens will return a 0 and it will not increment total. Sorry?
Any other exceptions?
Oh, yeah. Yes. Let's assume that someone verified that all these files are okay. Okay? We are not worried with exceptions now. Good attempt. There's another problem in this piece of code.
Can a total be adding, so new elements can adding total concurrently? That's a problem.
So we've got a shared variable, which is total. And depending on the speed of all the different threads that we got, okay, it might happen the situation that I was telling you about when I'm trying to sell tickets from a company, okay? So let's have a look at this, okay? So that's where the problem is, okay? So we got here my collection of threads. I am adding them to my collection. I'm iterating through all the threads. I'm creating here the threads, blah, 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 requesting the thread started, sorry, yeah, okay. Waiting for all the threads to finish. Yes, there's a problem. Let's have a look at this. I don't particularly like much this slide. Let's do it like this. So if I start this, okay, and I will go here this, okay. Okay, so I see. Good. So imagine that I got 1, 5, okay? Can you see here? 5, 1, okay? So if I look at my, I will start a thread and it will start counting, okay? And then I got my 5, 2, and it will start counting. And then I got my 5, 3, that will start counting, okay? So I got a common variable, which is the variable total, okay? So this is actually time. Oops, not really. Okay, this time, okay? From earlier to later. Okay, imagine that file 2 has 40 words, file 1 has 200, and this one has 3,000, okay? So, when I start running my I start running all these 3, right? Initially, total value is 0, right? So I do this one, okay? What is going to happen with total? 40, right? And then I will keep on going, and then it will be this one, and then I get the count tokens returns a 200, right? What's gonna do? What is it going to do? 160? No? 40, right? Because we got the plus over here, right? So it's going to be 240, right? And then, if I can keep going, right? And this one finishes, what's going to happen? 3,240. That's the behavior that we want to have, right? This is the behavior that everything is going to be working fine, right? But that's not what is going to be really happening, okay? So, let me see. It's not going to be happening in this order. What I got is that I'm going to start running my file, whatever one is 200, right? I'm going to create my 3 threads in this particular case, right? And this total plus equal count tokens will take some time to execute, okay? It's going to take some time to execute, right? And it's going to first calculating count tokens and then modifying my variable total. Imagine that for some reason, file 2, it's almost at the same time, okay? Finishing, it's almost at the same time. What is going to happen now? Okay? I'm modifying this situation, okay? Now I'm having that my file 2 is more or less at the same time finishing, okay? What I will have is, again, 0 at the very beginning, and then depending on which one is the one that finishes first, okay, my total plus equal count tokens F, okay, is total equals total plus count tokens F. So this is going to be happening and taking a particular time. What can happen is that first I get the 0 to, I compute the count tokens for imagine file 2, okay? And then I say, well, this count tokens is a 40, but my total is 0, okay? And this is for the file 2, but In the meantime, okay, I get the file 1, okay, and it's again total 0 plus 200. Okay, depending on which one finishes first, okay, what I will have is that I might have like they are kind of interleaved happening at the same time, and I get either a 40 or a 200, depending on which one has been faster, okay? And then this one that goes later, well then I will add, and then I will have either 3040 or 3200, okay? It's when, when they kind of finish very tightly together, it can happen that they are running this piece of code with still the 0, okay? That the other thread hasn't updated yet the total, okay? The total variable. And they all say 0 plus whatever, okay? So this is what is called, when this sort of thing happens, is called that there is a race condition, okay? It's like the threads are racing against each other to see which one goes faster, okay? And if they are more or less, very quickly, very together, very tight together in time, it can happen that they just give you the wrong result, okay? So, are there ways to actually fix this? Yes, of course, okay? Of course there are ways to fix this. And the solution is to make this operation, okay? See that I have broken it out now. Count tokens can be done offline. I don't care. But really, the operation that it is delicate, really, really delicate, is this one, okay? The plus, the addition, not the count tokens. Count tokens, you're not sharing anything. The problem is when you update the variable total, because the variable total is shared by all the threads, okay? So the way to solve that is by using a new keyword called synchronized. And what I guarantee with the keyword synchronized is that executing this piece of code, there will be only one thread at a time. Only one. Then in this way, problem solved, okay? I am first computing my count tokens, okay? And they will be all kind of, even, I don't care who gets there first, okay? I don't care who gets there first. I will say, well, now, whoever gets there first will say, what was now you do the addition, okay? It will get out from that piece of code, and then the second one, in this case, imagine file, so in this particular case, we were doing file 2, I was having a 0, I'm entering the synchronized bit of code, and I say, well, then 0 plus 40, I get out from the synchronized, and the 0 will not be a 0, it will be a 40, and I will get the execution that I had at the very beginning, where everything was very spaced, okay? So the problem with concurrency happens is when you are trying to share things and they go kind of together, okay? And then there is like some tasks that are accessing the shared resources, okay? Start touching the shared resource at the same time, okay? That's when the problems appear, okay? Good. So we can make pieces of code synchronized by using the synchronize these. I open the brackets and I do the operation, or I can even make methods as synchronized, okay? And I just place the synchronized keyword at the beginning, like a static, like a final, another one, synchronized. I can make that particular method synchronized, okay? Good. Is this more or less clear? Is it clear what's been the problem with the synchrony? Why do I need a code, such a keyword? Okay, it's to solve the race conditions when we're trying to, okay, who gets there first? Okay, The other term that it is important is that we are making sure with this keyword is that they are mutually exclusive. Okay, that's the key terminology that you use in concurrency. Okay, so I'm not inventing these words. Race conditions. That's the terminology that it is being used, and then you're using desynchronize to make them mutually exclusive. You will have only one at a time running that piece of code. Okay. Good. Now, here you get the sort of behavior. You will be counting that, and then you will obtain the log, and then you will continue. Okay. And yeah, you're avoiding having this concurrent and undesirable access to the shared value. Okay? Good. So now, the updated example is token counter 3, because token counter 2 didn't have the synchronized, and there might be situations in which it doesn't work. And actually, working with concurrency, this is why it is very big topic, and there are thick books, okay, about it, because it's very difficult to find the problems, okay? It's very difficult to, we could have just naively thought that there was not, yeah, I'm doing it right, things will be running well, okay? But if all of them are, but I'm not getting the right number, why? Debug that, okay? It's tricky, it's very tricky working with concurrent programs, okay? Because there are things happening simultaneously, and our brain is not that used to think like that. It's a little bit like recursion, where you are entering, and then you are doing, okay? And it's kind of like, okay, thinking an algorithm in a recursive way is kind of complicated, okay? So in this particular case, it's something similar. When you're working with concurrency, you also need to, actually span, you need to create multiple threads and realize about what is happening in your head, okay? With multiple things happening at the same time, and foresee what kind of problems. So the easier way to solve this problem is just to make synchronized this addition, okay? So it was exactly the same thing, but just synchronizing the calculation of the total, okay? The modification of the variable. Good. Now, well, this is a little bit insisting in the same sort of thing of how things are happening, okay? And making sure that at a particular point in time, only there is one operation of updating the variable total, okay? They are not happening at the same time. They are after this one has happened, after that one has happened, after that one has happened, okay? They will be sequential. Fine, good. More things. It's along the same idea, okay? Sometimes you need longer pieces of code that need to be executed. It's not just like an operation like this synchronized, okay? Sometimes you have multiple threads and you need to synchronize the execution, okay? And what means synchronizing the execution is that, for example, in a bank account, I cannot make a transfer of money from one bank account to another one until I don't have money, right? So I need to wait to have money, okay? So that's one potential example. Or if I'm trying to sell tickets, I cannot sell a ticket until I don't have the authorization to actually sell a ticket, okay? So I might need to be introducing something called waiting, okay? I might need to say, wait until something happens, okay? And the same way that I need to wait until something happens, I might need the other functionality, the complementary functionality that says, now, yes, you can stop waiting. You are allowed to continue. And that method is going to be the notify, okay? So we can have we will have the method wait, the notify all, and the notify, okay? In the wait is my thread is gonna be waiting, okay? The notify all is going to say, everyone who's waiting, keep on going because I have done whatever I have to do and no one could do anything in the meantime. Or I can say, now you, I notify you that you can continue, but not the rest, okay, only you. Does this make sense? Yes, one can think of situations in which you want to say, no, you just wait, now you continue, now you okay, organize the execution of threads, okay? So I can have, when I'm running my synchronized method, okay, that only one person, one thread is running that piece of code, I can say something like, why something happens, just wait. Until something doesn't happen, keep waiting, okay? This can cause problems. We'll talk about that. And when I have, actually, someone has told me that, when that condition is fulfilled, I can just continue. And I say, well, I can tell everyone to continue, okay? Good. This sort of wait and notifies can create a problem that it is called deadlock, okay? Where everyone starts waiting and there is no one that can notify and wake up anyone, okay? And then what you end up is just waiting. You got all your threads waiting. Does this make sense? Okay, so I can have 100 or 1,000 threads running concurrently. They can enter a piece of code like that one, and if for some reason all of them enter in the mode of waiting, they enter this piece of code, if there is no one that can notify them to keep on going, is when you got your program hanging, okay, and nothing, deadlock. Okay? So sometimes some of the problems that happen that, that we experience in our software, sometimes is because of this, okay? Some situations like that is like, okay, I am awake, I went to sleep, or I'm waiting for something, and there is a problem in how things were organized, and then everyone is waiting, and no one is notifying me, I cannot continue, okay? And then you just stay there, waiting for it, okay? We will see an example, a classical example to show this problem with the dining philosophers. Have you ever heard of that problem? The dining philosophers, okay? So basically the dining philosophers problem is you got a table, and you got a number of philosophers sitting around the table, okay? And they all got chopsticks, okay? Well, there is one chopstick between each of the different philosophers, okay? And the philosophers want to talk, and then they want to eat, and then they can wait, okay? But the problem is that there are not enough chopsticks for all of them, okay? Because there is the same number of chopsticks as philosophers, okay? So you have a protocol like to say, okay, take the right chopstick, okay? And then take the left chopstick, but if your, say, 5 philosophers start by taking the right chopstick first, when they go to get the left one, there is no one in their left. And, and then what you actually get is a deadlock situation, okay? Where, they are all with the right chopstick and they cannot eat, okay? Then we will look into how to break those situations, okay? And then you can say, well, maybe I put one of them that instead of starting with the right-hand side, with the right chopstick, start with the left. And then, since the one on my right will not do it, I get the left, the poor guy there, I'm sorry, but you will not eat at all, okay? Because you will not be able to get a chopstick ever. You get it, and then you get the right hand. But that one is going to be eating always. And the one next to you will not be eating at all. Okay? We will look into that, okay? There is a piece of code where we will run the different situations with the philosophers, okay? But it helps to think about it, that they are sharing a table, and then you are giving them orders about how to proceed. and you can enter situations in which one of them will just not eat at all. Okay? Or you can enter in this deadlock situation because they all did that and then they are waiting for someone to eat, and no one will eat because there's no possibility. Okay? Good, we'll look into that. Okay, so let's move on with the guarded blocks. Okay? So we can actually stop the execution and wait for something to happen, or someone to wake us up. And we are going to look into the example of a band. The class band